Hello, my fellow Almontians, and welcome back to another broadcast from the bunker. Today's hot topic, we're talking how are eroded sediments deposited from erosional agents. Lots of good stuff. Jumping to the do now, it's the new set of questions, right? 8A, numbers 9 to 12. Meet me there. Okay, start out number 9 here. The diagram below represents a side view of the Milky Way galaxy, not to be confused with the candy bar. So we got a side view here, kind of a profile view, at approximately which position is Earth, is the solar system located? Well, remember we said we're about 2/3 of the way out from the center and on one of the galactic arms. So 2/3 out from the center would either be here or here, right? There's no option there. And it's on one of the arms, so you got to go with choice B. From a top view, this would kind of look like a hurricane image. You'd still be 2/3 of the way out, and you'd be on one of those arms, which are clusters of stars. Okay? So we're going with B. Number 10. The diagram below represents a portion of the solar system. It wants to know what other planets, in addition to Earth, are there. Well, remember that little mnemonic, right? My very eager mother just served us nachos. Well, take a look. There's the sun. So, my very eager. Mercury, Venus, and Earth. And, of course, the little guy there is the moon, which, incidentally, folks, tonight, full moon tonight. It's going to be another one of those super moons. They're calling it a pink moon. So hopefully the clouds won't be out. Get on outside and check out the, supposed to be the nicest super moon for a while. So check it out. Okay. Going with Mercury and Venus. Scrolling on down here. Number 11. All right, it says, which photograph of star trails was taken by an observer facing directly north of New York State? Well, remember, if you're facing directly north of New York State, look up your latitude, obviously, and you'll see the star Polaris. And all the stars tend to go around Polaris. So if you're in that direction, you got to be looking at a star in the middle with stars going around it. So you got to go with choice D. Okay. And label your star in the middle there. That's Polaris. All right. The rate at which the stars go around Polaris equals the Earth's rotational rate, right? 15 degrees per hour. Last one on the do now, it says to an observer located at the equator, on which date would the sun be directly overhead? Well, the sun is directly overhead the equator on equinox days. So that's either the March 21st or September 22nd, plus or minus a day, right? Don't be stubborn on that. And you'd have to go with March 21st. Right, over the equator on equinox days. Whoa, that's some funky handwriting there. Equinox. Days over the equator. Okay. Okay. Any additional questions on those? Head to... I'll make a comment down in the section below. All right, let's jump to the lesson today. All right. Once again, makeup labs have been posted to the GC. If you need to make up a lab or two, head on over to the GC, see if those are one of the ones you are missing. Okay, erosional agents. Well, I wanted to start out talking about a little bit of wind. A couple of videos on wind erosion, quite mesmerizing. How does the wind deposit sediments, you ask? Well, watch these mesmerizing clips. All right, check this out. This is sand blowing on a beach. Looks eerie, right? Kind of like clouds moving in. Fancy word, they call that is saltation, but it's simply the wind blowing the sand there. Nice and relaxing. Now that's a beach setting. Check out more of a, let's see here. This is a desert setting. And you can see as the wind comes over the slope there, it kind of drops down. And that's a classic characteristic of wind-blown sand formations. This guy must be looking to get a sand-blasted facial there, right? And one other one I'll show you here. This one is a very high-speed wind here. Check this out. Really whipping across the landscape. Right, pretty wild stuff. And that's why if you do ever get caught in a sandstorm, you definitely want to cover up, because little sand grains, they're mostly quartz, so they're pretty hard to have sharp angles on them. They tend to scratch your face. Okay. How are deposited sediments sorted? Well, when the wind blows them like that, it blows them across the land. It kind of sorts them out in a horizontal fashion, and of course gravity pulls them down. But it sorts them out from this left to right pattern, if you will. And it's a similar thing when water flows, right? When the stream goes into the ocean, it slows down and gravity pulls them down. And the first thing that's going to get dropped out, remember from yesterday, are the bigger, heavier sediments. So we're going to start, the first thing getting dumped out are boulders. And then, of course, you'll get your cobbles, your pebbles, eventually your sand, eventually your silt, clay, and all the way out there would be where the water evaporates and the minerals precipitate. So we labeled this diagram for you, right? Boulders, cobbles, pebbles, sand, silt, clay, and precipitates. And if you relate that to the rocks that have formed, this is how Mother Nature sorts them out. So over here you get your conglomerates. This would be your sandstones, siltstones, shales, and these would be your chemically formed sedimentary rocks, right? Your chemical limestone, dolostone, etc. All right, it's called a horizontal sorting, and of course it goes in that order there. So make sure you get this into your notes. Okay, these are some regions diagrams on rivers doing a horizontal sorting when they enter an ocean. And it kind of spreads out and makes this neat feature called a delta. All right, there's your definition for that. And if you look at the bottom right there, that is the Mississippi Delta. Very, very pretty. Where it, all the sediments being carried from the United States end up in the Gulf of Mexico. And it's called horizontal sorting. All right. How about quiet waters? What if there was no river flowing? What if they were just dropped into a lake? Well, now they don't sort out horizontally. Now they stack up like pancakes, and they call it vertical sorting. And again, the big goes down first, medium, small. Next year, right, big, medium, small. And we mentioned this yesterday. It's called graded bedding or vertical sorting. All right. Smallest, flattest at the top, and the largest, roundest at the bottom. All right. Vertical sorting, a.k.a. graded bedding. And this often happens seasonally, but also if you get floods, you'll end up eroding big stuff, and the flood will slow down, and you'll get little stuff. And this happens year after year. All right. Vertical sorting, quiet waters, sediments are sorted vertically from large at the bottom to smaller at the top. All right, it's a little more, just a different way of looking at it. That's how it looks in nature. You can see big, medium, small, big, medium, small. The knife is there just for scale. Okay. Glaciers, however, aren't like wind or water. We said they don't sort out at all. They are unsorted. They're like bulldozers. And they call it till, unsorted sediments. Now, Long Island is a bunch of till because we were dumped here by a glacier. All right. Outwash plain is when that ice starts to melt and it'll pull the smaller sediments out, right? That's our South Shore. Good example there, where you get all the sand at the South Shore because when the ice melted, it pushed these smaller sand grains downhill. All right. The erratics we mentioned the other day, those giant boulders in the middle of nowhere, well, they must have been brought there by a major force of erosion, right, a glacier. And usually the rock is different than the rock below it, so it's another clue that it must have come from someplace else. All right. You'll get these things called drumlins. We mentioned they look like duck heads, right? But the other thing we didn't mention was kettle lakes. Kettle lakes are giant blocks of ice that broke off of an ice sheet and laid on the land, and they pushed down this big hole, and then they melted, and you get this cool-looking lake in the middle of nowhere. All right? Famous one, not far from Elmont. It's called Lake Ronkonkoma. Maybe you've heard of it, maybe you haven't. Back in the day, it was, an amazing place to go, kind of like the Hamptons type of thing. Unfortunately, the lake got quite a bit polluted, and now the area is, not as desirable, and you certainly wouldn't want to go swimming. But how it happened, you get this giant block of ice that broke off of an ice sheet during the Pleistocene. They figure about 17,000 years ago. And when the ice melted, the water filled in the hole, and that's Lake Ronkonkoma. It's about 65 feet deep, which is pretty impressive. That's quite a depression. That must have been a huge chunk of ice. And the whole area takes up about 243 acres, so it is quite large. It's too bad it unfortunately got polluted. It's not naturally fed by rivers and things like that. It gets refilled and fluctuates with groundwater, whereas many other lakes will have a river coming into it and a river going out, and it constantly gets filtered. This water kind of stays there. All right? Kettle Lake Ronkonkoma. All right, then we get down to the ocean. How do waves cause erosion and deposition? Well, they call it the Longshore drift. And the South Shore Long Island is a great example of that. The water just kind of does this zigzag pattern, and it pulls the beach sand all the way from Montauk Point all the way towards Manhattan. So that if you, put a message in a bottle, if you will, over here, eventually, of course, it would end up very, very far away. They call that the Longshore drift. And it's a type of beach erosion. It happens all the time. And that's why they keep dredging. They'll bring sand up onto the beaches to prevent erosion from completely washing them away. Okay? And there it is. There's that transfer of sand as it heads across the shore. All right? To try to stop that, we build these things called jetties. You probably heard of them. Maybe you've even seen one. I know the Rockaways has them. Long Beach has it. And what it does is it tries to slow the water down. And if you slow water down, it's going to deposit sediment, which prevents it from getting eroded. So a lot of people will walk out on there to do some fishing. You got to be careful. Those rocks tend to be slippery. But when the water hits it, it slows down, and you see more deposition here and erosion on the other side. So they are effective, but unfortunately, now you'll end up getting erosion in a different place, deposition in another place, so it's not perfect. But it does slow erosion down. This is not they call this a breakwater. So it's not connected to the beach, but it has a similar purpose. Can you think what its function is? Well, yeah, similar thing where as the waves come in, instead of slamming the beach, they'll slam this, and they'll prevent the sand from getting washed away. Okay, this would be down by like JFK and the Rockaways area. All right. All right, couple of summary questions here. Which characteristic of a particle would usually result in the longest settling time? Well, that means it took a long time to settle down, so it must be small, flat, low density. And hopefully you pick choice 2. For the second one, transported sediments are usually deposited at locations. Well, where are you going to deposit things? Hopefully you would choose there where things slow down, a decrease in the speed of the wind or the water, the erosional agent. Okay. All right. Well, folks, you know the deal. Any further questions, post them in the YouTube comment section below. Again, please read this. That's how your hand-in works, so your grade is a true reflection of the effort you've been putting in. grades are being calculated very soon, so get on that. And there, of course, where you submit questions. All right, folks, get outside. Another beautiful sunshiny day. I'll see you tomorrow.